You know that glass jar of pickles or jam sitting in your fridge? It looks so simple, right? Well, what if I told you its journey to your kitchen shelf involved liquid fire, an invisible coat of armor, and a futuristic gauntlet of lasers? Let's crack open the incredible story of how that jar is actually made.
Have you ever really stopped and thought about it? How do you create something so perfectly clear, so strong, and so safe that we trust it with our food every single day? Because believe me, the actual process is way more complex and honestly, way cooler than you could ever imagine.
It's this wild ride that starts in a furnace, hot enough to melt sand into liquid, and ends with a series of high-tech inspections that are just mind-blowing. So let's get into it. Let's follow the journey of the humble glass jar.
Okay, so before we dive into the furnaces and the machinery, let's just ask a really basic question. Why glass in the first place? Why is this stuff our go-to material for protecting our food? Well, it turns out there are some very, very good reasons.
It pretty much boils down to this. Glass is the ultimate bodyguard for your food. The most important thing is that it's inert. That's just a sciencey way of saying it doesn't mess with what's inside. It won't react with your food, it won't leach any weird chemicals into it, and it keeps the flavor exactly as it's supposed to be. It just works. That's why we see it as the safest, highest quality choice.
All right, this is where the action really begins. We're heading into an environment of pure liquid fire. This is where basic raw materials, we're talking sand, soda ash, and limestone, get completely transformed into the molten glass that will become our containers.
And yeah, you're seeing that number correctly. 1,500 degrees Celsius. That's over 2,700 degrees Fahrenheit. It's an insane amount of heat, but you absolutely need it to melt everything down into a perfectly uniform, bubble-free liquid glass that's ready to be shaped.
So you have this giant river of molten glass. How does that become one single jar? Well, every single container starts its life as something called a gob. You got to remember that word. Think of a gob as the DNA for the jar. It's this perfectly measured, glowing hot teardrop of glass that has the exact amount of material needed. No more, no less.
So, how do you get these perfect gobs? Well, imagine this stream of red-hot, honey-like glass flowing out of the furnace. Then, a giant pair of super-fast shears comes in and snip. It cuts off a precise little cylinder. Each snip creates one gob, which then drops down to shoot to the next stage. It's an incredible, high-speed ballet of machinery.
Okay, so we have our red-hot gob. Now what? It's just a blob. It needs a shape. This is where the real magic happens, and it's not a one-size-fits-all kind of deal. There are actually two main ways to forge that final shape.
Now, this might look a little complicated, but the idea behind it is actually pretty simple. For a wide-mouth container, like a pickle jar, they use what's called press and blow. A metal plunger literally presses the gob into a basic shape. Simple. But for something with a narrow neck, like a bottle, they use blow and blow. Instead of a plunger, an initial puff of compressed air does the shaping. So the key takeaway is super easy. A plunger for jars, air for bottles.
And after all that pressing and blowing, here's what you get. Our finished container. You've got the finish at the top, that's where the cap screws on, then you have the body and the base. Every single part of this, every curve, is precisely engineered for strength and for doing its job perfectly.
Now, you'd probably think we're done, right? The jar is formed, it looks like a jar, what else is there? Well, not quite. See, freshly made glass is surprisingly delicate. If it bumps up against another jar on the production line, it can easily get scratched or damaged, so it needs a coat of armor. And this armor gets applied in two separate stages. First, while the jar is still incredibly hot, it gets what's called a hot end treatment. It's a microscopic layer of tin oxide that basically toughens up the surface. Then, after the jar has been slowly cooled down, that's a process called annealing that removes internal stress, it gets a cold end treatment. This is basically a lubricant, a slippery coating, that lets the jars glide past each other on those super fast filling lines without shattering. So our jar has been born in fire. It's been shaped, it's been armored. But now it faces its final and toughest challenge, the gauntlet. Every single container has to pass a brutal, unforgiving series of automated tests to make sure it is absolutely perfect. And these inspection machines are not messing around. They look for any flaw and sort them into categories. A critical defect, something like a microscopic crack that could be dangerous, means that jar is instantly rejected, gone. Even a major defect, something that might just jam up a packaging line down the road, gets it tossed. The standards are just unbelievably high.
And this just gives you a sense of how intense this gauntlet really is. You've got high-speed cameras scanning for any visual flaws. You've got sensors using light to check wall thickness down to a fraction of a millimeter. They even use jets of air to test the ceiling surface to make sure it's perfect and won't leak. It is a relentless, high-tech assault course where, honestly, only the flawless survive.
So, from a 2,700-degree furnace to a high-speed gauntlet of light and air, that is the hidden journey of your everyday glass jar. It's not just a simple container, it's a tiny marvel of some serious engineering, all designed to do one thing perfectly: keep your food safe. So the next time you twist one open, maybe you'll see it a little differently.